Please give a very warm welcome to Paul Cogging and SS7 for INFOSEC.
Thank you, sir. I'm Paul Cogging. I'm from Alabama in the U.S. My background is network infrastructure. I spent 20 plus years building network infrastructure for telco service providers and large enterprises. And in addition to that, spent a great deal of time working with red teams. That's what I do today. I'm work on a red team, penetration testing every day, focusing on the network infrastructure parts of the network. So what inspired this talk is I spent over 10 to 15 years working with telco service providers, specifically building out MPLS, the telco, IPTV, the soft switch network infrastructure. And I never really dove into SS7, but I'm like everyone else, I'm reading everything about SS7, how SS7 is being hacked and stuff. And so I'm like, okay, well, how would you get access into the SS7 network to do all the evil that everyone is talking about with SS7? Because I'm reading some really good papers, and they got me all scared and terrified of the whole SS7 and 4G protocols. But how do you get that handhold? So that's what I'm going to try to attack in this presentation. As how does the attacker get access to the telco so that they can get into the SS7 network to try to stay still the two-factor authentication, your text messages, et cetera. But how do they get that initial access into the network is where we're going to go with this talk. So a little bit of background on SS7. SS7 has been around since like 1975, 1980s, when it started getting developed by AT&T. Whenever your phone calls are leaving the central office switch, there'll be an SS7 call connection being set up. Your 800 numbers, SMS text messages between different locations, all that is going to be built on SS7. In the U.S., if you have an emergency, we call 911. I don't know what, depending on where you are in the world, you have different numbers you call for emergencies, but in the U.S. we do E911. All of that depends on SS7, your caller ID, et cetera. It's going to depend on that SS7 service. Now, in the SS7 infrastructure, there's different nodes that build out this infrastructure. You have the STP, the signal transfer point, and for me, I'm an old school router guy, so I think of the STP as a router, and it routes the messages. And also, similar to a router, it has filtering capabilities. Well, in all my research, what I discovered, similar to a lot of the networks out there, even though a router has filter capabilities, not everybody uses those filter capabilities properly to protect their network infrastructure, as we'll discuss. And then you have a node, it's called the service switching point, and that is like what they call a class 5 switch, and that'd be like your phone system, like your PBX in your enterprise, but it's the class 5 phone switch instead of a PBX that can scale to tens of thousands of users. Subscribers to switch phone calls. And then you have the SCP. And the SCP, the service control point, is the database that has all the subscriber information, the 800 calling card information if you're using calling cards, and other services. The mobile subscriber databases, that's what they're going to refer to as the service control point in this SS7 network. So here's how it all ties together, a high-level architecture. The STPs, basically the routers for the SS7, they're going to tie together with what they call B-links. And if the STPs are clustered together, they would use C-links, and those C-links are going to be transferring network management traffic. If the B-links were to get oversubscribed, some subscriber data might go over the C-links, but most of the time it's just management information. And then you have A-links that are tying together your SSPs and your SCPs. And then you can have those SSPs also tied together with F-links. Back when I was initially building service providers back in the early 2000s, I was familiar with the A-links because the ISPs, when the dial-up guys, it would get to a point economically where they would have so many PRIs, E1s or T1s, depending on where you're at in the world, that if they had enough infrastructure, it would get cheaper and more economical for them to move away from PRI links to go to A links to terminate their dial-up modem traffic in some cases. So, but we don't see modem traffic much anymore, right? And so here's what an example of a traditional cellular network architecture might look like. This is not the 5G or anything like that. This is more traditional GSM, where you have your antennas, towers out in the field with the base station controllers that are going to tie back to a mobile switching center, where you have what they call an HLR, the home location registrar, that manages the phone subscribers back at the central office for the telco. And then you'll have VLR, which is the visitor location registrar, and that keeps up with the roaming of the mobile devices. And you got the equipment identity registrar that keeps up with all the equipment, whether it's recognized or not, whether it's been turned off, et cetera. And all of that network infrastructure is going to tie into the global PSTN SS7 network. Now, I'm an old school network guy, and I like to see a packet. I like to see a Wireshark PCAP. Now, I know this is hard to read, but you can. If you want the slides, I'll provide the slides to you where you can look at this offline. But here's an example. I wanted to show a PCAP real quick of an SS7, and you can see it just goes from a frame down straight into the SS7 protocol. And the SS7, instead of having 7 layers like you might see in a Wireshark PCAP for like a typical IP Ethernet connection, what you see is it goes the frame and then it's straight into the message transport part. And so it's just 4 layers. And what I have circled there is where you can see in the packet capture there, where there's a calling number and the called number, the source and the destination being phone numbers. And this was captured straight off of like a E1 T1 line. With like a T-Bird set, you wouldn't capture this with your standard laptop. You'd have a specialized test set that would have to capture this frame. Now, we're not going to dive into the 4G, 5G piece, but just real quick though, I wanted to show with when we go into the 4G and 5G, it's all of this SS7, all of the signaling, the mobile signaling goes into IP, as we can see here. All of the signaling is encapsulated into IP, which makes it more versatile, makes it easier for the telco service providers to consolidate their infrastructure down to one big infrastructure, say like MPLS, transport networks, where they can carve up the network and multiplex multiple services across the network using IP instead of having to have dedicated networks. But it also, from a security standpoint, it enables the network to be easily targetable because it's all on IP, right? So here's where the focus of this talk is because I started thinking about this of how do you get into SS7, how does it work, and how do you get into that to the SS7 network. These telco service provider networks are comprised of dozens of vendors. And at the top, what we show here is where the brains of the operation is, where you have if you're an old school router guy like me, you're familiar with Cisco Works, HP OpenView, Network, NetCool, Tivoli, et cetera. Well, the telcos, all the different services that they're providing on their network, the IPTV, the cable TV, where you're clicking your channels to change, changing cable TV channels mapped to multicast groups, all that in the IPTV head-in, your voice over IP, your SAW switch, all of including the router infrastructure, all of that has network management systems for automated provisioning. And also they're going to have like capabilities in case the government wants to do a wiretap, an IP-based wiretap, so they want to go and look, track organized crime or suspected terrorists. They're going to have the lawful intercept capability in the network infrastructure up here at the top with all the AAA, et cetera. And then you're going to move down into the infrastructure where they have their DWDM, where they're multiplexing different light wavelengths across fiber. So you might like have 80 different colors of wavelengths running across the fiber, which we call lambdas, maybe 80 different lambdas, where it's being multiplexed across that infrastructure. And you got your MPLS router infrastructure possibly here. And you get down to the edge where the network services are being provided out to the customers and aggregated. And you see, in the US we use Sonnet, which is going away. Sonnet and SD, in the US, Sonnet is going away really, really quick, and I'm sure it is here in Europe as well. If in Europe it would be SDH instead of Sonnet. Where you'd have the traditional TDM services, and that's what the legacy SS7 is going to be tied in with, is the legacy TDM services, how it's going to connect in. And then you get into like the fiber to the home, whether they're using PON or passive optical architectures. But the key piece I want you to get from this, and we're going to dive in a little bit deeper, is all of those systems have lots of different vendors, and what I've seen is some of these vendors will specifically write into their contracts. I've got a contract at home I use as an example to remind me how crazy things are, that they write into their contracts that they will have access, remote access into that network, and they're going to have it the way they define it. And what I've seen is in many cases with some of the vendors, and I'm talking about big name vendors, they put in a Linux box that's multi-homed, one leg into the sensitive network management operations network and another leg accessible to the internet. And it gets approved because what happens in these organizations, everybody's got their own business model and their own revenue streams, and they answer up to the CEO through their own management chain, and they have their own budget and their own, politics. I know politics are universal, right? And you got the internet guys who understand security and understand all this IP technology, you understand the hackers, and you have the voice guys and the cable TV, video, IPTV guys, and they have all their own budgets, and they have their own favorite vendors. And what I've seen in many cases with this infrastructure, the voice team and the cable TV team, they really don't understand this IP technology, and so they lean on the vendors to take care of everything for them to keep them gainfully employed. And whatever they say, they get. Whatever the vendors want for those parts, they get, and they'll fight the internet people who understand security to stay out of their business. And so they're able to go and drop these boxes in that are insecure, and that's what ends up opening up back doors so that someone can go, once they get access into the telco, they can start pivoting and gain further access into the network. And I'm telling you this because I've been getting I get phone calls in my previous job when I was doing security consulting with telco service providers. I'd get calls in the middle of the night, we've been hacked. And this was when we'd run it down, and this is what had happened. So here's coming up with a strategy to go after a telco service provider if we were under authorized contract, or if you're a bad guy, you could do this as well, of course. But assuming we have we're all ethical hackers, assuming we have a contract and we're supposed to go after this network, some of the ideas I would go out and go do the recon, get the press releases, get on LinkedIn, find out what everybody's bragging, of course, about all the systems that they have on the network, all the vendors, and reverse engineer and try to build out and understand how that network is put together and what might be the inflection points into that network, depending on what kind of handhold we get and how we can pivot further. And I like to develop attack trees before I go and attack a network. If time permits, I like to develop a really detailed attack tree of the strategy based on all the intel that I gain, build out which the attack tree is nothing but a new marketing term for a flow chart, but attack tree sell. Management loves that term attack tree and all that, but it's a flow chart, right? But what I've discovered I started doing pen testing in '99, and whenever I start doing these attack trees, and if I can go and if the team can do a really good job of building these attack trees, we're usually successful. We'll find a way in, and we can figure out how to pivot around in the network, if the rules of engagement, depending on limits of the rules of engagement we're in. So here's an example. This is a real world example, minus all the vendors and customers to protect me, my liability. But I've seen this happen multiple times where you had the transport vendor, like the system that's going to be running the optical network, that's providing the backbone infrastructure, like I was mentioning earlier. They would have its own management chain and their own budget that's separate from the team that understands IP protocol and how the network and security works. This team or the soft switch team, because what happens with the soft switch team is you have the traditional class 5 switch, which may fill up a room this size, where there's just racks and racks of equipment. They might fill, depending on how big the city is, the central office, it could possibly go from the podium here back to the wall, just racks, rows of equipment to represent that class 5 switch. And when they go to a soft switch, they get down to where all that space goes to a rack of a couple Solaris boxes. And the gentleman and the team that used to manage that traditional class 5 switch, they don't know Solaris, they don't know Linux, much less they don't know IP. And so what happens, those vendors are able to go in and put in these, what they call EMSs, element management systems, basically network management. Think of it as Cisco works for a router. Their management system for whatever their product is, and to make sure that when their customer needs help provisioning, they have questions, they need help troubleshooting, they'll put those servers in there on the route, multi-homed in that network. And what I've experienced personally, I don't know what, if you have experience with these, you might have seen different things, but what I've seen is they drop these boxes in, and they use the same username passwords everywhere, and people just go out there and they just SSH brute force until they get in. The only thing protecting them is SSH, and you're typically easy to guess passwords, and they just brute force. And what I've seen in numerous cases, they don't even know they've been hacked until eventually someone hacks their system, and their IDS. The IDS is this is a true story. The IDS is a bank in Europe. Some bank in Europe will call them and tell them to cease and desist attacking us using their soft switch or their network transport, network management system. And there's no telling how much other access other people have gotten into their network, but that's usually the IDS. They're in how they find out that system's been hacked, because it totally bypasses the network security that the IP team has put in place. Totally bypasses the firewalls and everything, because they're making money. It's all about making money, right? So here's another idea, and this is based on a true story too as well. Real world scenario, minus all the details to protect me about the liability. What you have here is a real high level network architecture diagram of the transport infrastructure. And what I've seen in one case is there was a enterprise customer. They flipped their network from frame relay with one customer over to frame relay with one provider to a frame relay with a second provider. The first provider wrote off all the hardware, because the first provider was providing all the router infrastructure out to the customers and managing it. When they flipped the contract, went to the second provider, the first provider abandoned all of the router equipment at the customer site. Abandoned it, didn't want to pay for the cost of shipping it back. The customer bought new equipment for the existing network to do the migration. Then they doubled in size. And so the customer's like, hey, we got all this equipment that's been abandoned. We're going to reuse all that equipment. They do password recovery on those routers, and guess what was in all those routers? All this stuff down here in the bottom right. If you've got experience configuring routers, all of the SNMP community strings, both read and read write, all the router passwords, the AAA IP addresses, the AAA passwords, the IP addresses of all the IP addresses of the AAA, the network management systems that are trusted. And from that, you could reverse engineer how the network operations center and the security operations centers was architected, because you get the IP addresses of their NetFlow boxes, what IP addresses are collecting logs. So then all you have to do is take that information that you collect from this router. In another case, you might get it off of, say, eBay or something. Then you could turn around, one easy way to gain access to the network is just go back out to LinkedIn and figure out who works for the telco that you're going to target. And once you fish them, get on their system or their home system, their work laptop, what have you, and then piggyback on their network connection. And now, because of all the intel you've gathered, when you get in that network exactly what they go target in the heart of their network, their knock sock. You piggyback in, and you can be very surgical and not make a lot of noise searching the network. You can make a surgical strike and go straight to the heart of the network. And then from that, depending on what your access is, what I've seen, I don't know what your professional experience is, but once you find out that VLAN, you get into that part of the network where the network management, the operation support systems are, it's usually big flat VLANs. Big flat VLANs with all the vendors, and if you can just get into one vendor, you end up being able to get into everything. And from that, then you can go and pivot and get into, say, the soft switch network. In the soft switch network, then you can go and pivot and get into the SS7 and influence the SS7 or the 3G, 4G network. Now it's going to 5G. You can then pivot into the heart of that infrastructure and start influencing the SS7 network, or the SIP, et cetera. Here's real basic SS7 attack that I was researching. One of the first things they're going to do is someone goes and they do what we were just talking about. They get access into the telco network. And they're inside of the voice network. Maybe they're on the soft switch. They get into that soft switch infrastructure. Then one of the first things they're going to do is try to get this MC ID, which there's a number tied to your phone, not just your phone number, but there's a number called the MC number that they're going to need. And then they're going to send a query. They're going to craft a packet or a frame. They're going to craft an SS7 message and send out to out to the network to your HLR, your home location registrar, to get that MC number. And then when they get the response, they're going to know your HLR. They're going to know your VLR, your visitor location registrar. They're going to start getting a great deal of intel once they start sending queries into the network. And then from that, once they have that MC, they can start doing more surgical strikes and do things like try to find your location. Now, this anytime interrogation message that for finding the subscriber's location wherever they may be in the world. This on most of the SS7 networks, all the research I've been doing, this is being disabled, but there's a lot of SS7 networks where it has not been disabled because the people running the phone systems may not be aware and might be have a good understanding of security in there, depending on their vendors to do those kind of configurations for them. And until somebody from a government agency shows up or someone calls them complaining, they're not going to fix it. They're just doing operations, punching, doing whatever it is they do daily, because the internet folks may not be involved with this, that understand security. But typically, like I said, this anytime interrogation message is going to be disabled, and they could disable it with an SS7 firewall or at the STP. Another way to go and find the location of a subscriber is if they get access into the SS7 network, then they can maybe spoof a home location registrar, craft packets, craft SS7 messages, and send them up into the SS7 network because they have the MC number, they know the home location registrar information and the visitor location register location information, and they can send those crafted messages up into the network and then pull back identify the location information and find out where a subscriber is somewhere in the world. Now, what particularly interests me, since I specialize in network infrastructure attacks and things, I like to look at all the ways to do man in the middle, whether it's inside of a network, inside of an internal network, or like doing BGP hijacking to do man in the middle, et cetera. So it interests me that how you can use SS7 to do a man in the middle to say capture somebody's text messages and maybe modify the messages or just capture them and forward them on. So it's possible if someone has the access and they know what they're doing that they can craft messages and impersonate the mobile switching center and send messages up to the home location registrar and find out where that's just, and update the network and say, hey, if anybody calls looking for this phone, this is where they're located. Kind of like the ARP poison, where you go poison the cam tape, the MAC address, the ARP cache. But instead of poisoning an ARP cache, in this case, we're going to poison the subscriber database. So on the home location registrar, so that anybody that's looking for that phone will come to us and swing their traffic over to us, and then if we can either capture it or we could forward it on, depending on the capabilities of the setup of the attacker. So a few things to consider. There's a couple tools out there for attacking the SS7. I have not used these tools myself. I don't have a SS7 lab to test with yet anyway. I'm hoping to build one. There's SIGPloit that's out on GitHub. The guys at ERNW developed a tool called SS7 Mapper. At ERNW, Eno Ray and his team, they've got some good papers out there on both 3G, 4G, and I believe they have some research on 5G as well, where things are headed with those protocols if you're interested. You could use SCAPI or Colosoft Packet Builder to craft messages. If you have that access into the network, that you could use those, you could use SCAPI to roll your own tool to send SS7 messages up into the network. Now, there's also specialized firewalls for the SS7 network. I personally, that's one of the things that really surprises me, because I spent years and years and years, since '99 I worked with telcos, and I never saw an SS7 firewall. It was never discussed, never heard any conversations about it, and I spent a lot of years in telcos, did tens of millions of dollars in network implementations and consulting in telcos, and never was, we talked about IP firewalls. We never had a discussion about a firewall in this. We talked about session border controllers, SBCs, for SIP, but never for SS7. That was never a conversation. So, but apparently there is all these firewalls that are specialized, like this, the Celesys, Fortis, and the STPs. Similar, like I said, the STP is a router for SS7, just like you might have a Juniper or Cisco or Brocade router for your IP network that can do access control list. Well, the ST, like I mentioned earlier, the STP can also do filtering, and you can turn on filters on that node. Like I said, I got into pen testing in '99, started working with the telcos, service providers, doing both building the infrastructure and doing security audits, but it was always focused on the enterprise side of the telco or on the IP side of the telco infrastructure. I've never had an engagement when I was doing security consulting for the service provider. I've never had a security engagement where we looked at the voice infrastructure. Didn't look at the cable TV either, because those vendors have that stuff locked down, and they don't want anybody touching it and breaking it, and their management teams will protect it, and the politics will protect it. But I think a big focus needs to be, especially if you're working for a telco service provider, need to go and allocate some budget and find a team that's qualified to go in and test that network. If it's a legacy network, if it's old, if it's the older systems, I would treat it like a legacy ICS SCADA system. So that, if you go in there and start turning Nmap loose and Qualys, Nessus, you might roll something over. You don't want to be that person that crashes that old box that hadn't been patched and updated. You don't want to be that guy. I've been that person, caused the blue screen of death. It's a bad experience. But in the newer stuff, the newer systems that have been rolled out, they'd be okay to go and probe. Most likely they're more patched and up to date, can deal with the scan. But these networks need to be audited. They need to be audited, and they need to be pen tested and understand their security posture, and be tested just like we would the typical internet infrastructure, either on the public side of a service provider or inside the enterprise operations for the service provider. The voice networks need to be looked at just as much, because what I've seen, it's neglected. And also these vendors. The vendors are coming with these contracts and want all this remote access, and you have to grant it to them if you're going to buy their system. And they do need their help, because there's some complex technologies that are being rolled out. But there needs to be some best practices, putting two-factor authentication in and being able to identify that the vendor, the field engineer that's coming in to help you, is actually the field engineer that you trust, then have some ways of vetting and verifying, and not just give unchallenged access into your network. Because what if they, because engineers go rogue, right? They go bad. There's examples all the time where the whole insider compromise. The vendors have the same problems that the enterprise does, and get get visualization and instrumentation on that, where get the net flow, get the PCAP, and know what's happening with that voice network just the same way we do with our internet infrastructure. Get some visibility on it, because my experience, they have no visibility outside of whatever logs they have going back to the element management system. But we need to go and be able to go and see who's talking to who, where, when, and how much, when it started and stopped with net flow, J flow, S flow. Get that kind of and get PCAP capability to understand these communications of how somebody is remotely accessing those voice networks, and see if ET's phoning home from our voice network, and wait, instead of waiting for a bank somewhere in the world to call us and tell us that our soft switch is being used to attack them. Yeah, because I think about that network. How much of their traffic might have been being captured before the vendors got notified to come in? How deeper was the attacks? Because I had one experience. The telco service provider had a vendor in their network, and the vendor got hacked. The vendor got hacked, and from the vendor, their customers got hacked. And how I figured out what happened is the vendor showed up with a free upgrade, hardware and software and engineer, no charge. Now, I'm a country boy from Alabama, but I ain't dumb. Ain't nothing free. Ain't nothing free. And they come in with new hardware, new software, free services. And so I started social engineering the engineer that showed up. You know, you go to lunch with them, you talk to them. The more you build a rapport, they start talking and telling you things they shouldn't. And I found out that they got hacked, and they come in with a free upgrade. Nobody did any forensics. So I always wonder what was happening with the customer information and things of that. And then on top of that, were there pivoting and escalation of privilege across other segments of the network? But I don't know. New bots got put in, hacked bots got ripped out. No questions. Everything's good. It's a free upgrade. So I got a lot of reference. If you're interested in digging into SS7, like deeper, like I said, I'm not an expert on SS7. I'm just interested in it, so I wanted to understand how to attack it. So here's a lot of references. A lot of really intelligent people have written some really deep papers on SS7 and 3G and 4G that you might be interested in. Here, there's some of them that I read through. That's what I have. Anybody got any questions or comments, criticism?
Thank you, Paul. Nobody fell asleep, so...
Yeah, that's good. That's a surprise. Nobody's snoring.
You had your hand up earlier.
Some comments. So I'm from a vendor. I'm from Nokia. And I can confirm that we don't have hard-coded backdoors in our products, just to make sure that there's no misunderstanding. We do patching, so we are able to patch our customers, but that's according to the contracts. So some comments to your, for the SRI SM attack, I mean, that's easily mitigated if you have home routing,
Okay.
and if you have proper encoding between the different encoding standards. The ATI command, which is usually used between the base stations,
Okay.
is an internal command and can be easily configured to be filtered out at the STP, at the edge of the network.
Okay.
And that's actually the operator's duty to configure, because we don't know all their base stations, because they have a mix and match usually of base stations. So we don't know all their base stations, so we cannot configure it for them. So just as background. And 2002, there was something called MapSec standards defined by the vendors in 3GPP, but it never took off due to customer lack. So, and if the customer is not interested, well, as a company, as a stock-owned company, you don't implement it. That's it.
Yeah. Well, that's like port security. Yeah. Port security is available on the network, but who's implementing it? So you can plug into an enterprise and do a ARP poison with a vulnerability from the 80s still today, but you got it mitigated, but nobody mitigates it in most cases. Very few do.
So my question is, you've talked about all the boxes connected to the different types of networks like telcos and IP and all the stuff. Have you encountered any dial-in or dial-up access, like out-of-band, based on ordinary modem from like 1980s, to access those systems?
Yeah,
so
if you're
getting back to
yes,
good old war dialing.
Yes, that's a good question, and I'm thinking of a one network right now that needed to be audited, where I actually saw the U.S. robotics modems stuck up in between some equipment that was backdoor, but I was not permitted to interrogate and go very further because of politics. I got told to get back on my rack. But being a security guy, I had to ask questions. You see blinky lights. Oh, what is that blinky light? I don't know that box. Where does that put? They're like, that's our rack. You get back over here on this internet rack. You do routers. You turn on MPLS. Don't worry about this over here. So yeah, you still see it, but more and more what I see is remote access over IP. But the modem stuff's out there, especially for the legacy equipment, because the dial-up is dying really, really fast. Most of the telco service providers I've gone to, they still have some modem banks because there's some customers that are still holding on. believe it or not, and they still have the modem banks blinking, and then they still have it. But most of it's being turned off, because the vendors are requiring that remote IP access, because the vendors that are going to be supporting them and their technicians in-house don't have dial-up, because it's all IP. But you still see some of it out there. A lot of times maybe they forgot about it and it's still plugged in some legacy equipment that just hasn't been turned off yet. And that's what you look for. Because what I found when I've been able to look at for it, especially on like routers, it'll drop you right into a shell. If you can find it, if you can find the number, you might get lucky, and because they didn't configure it to timeout, and it's still logged in. Yeah, it's wonderful. Has job security, right?
Further questions? There was another question down here, I think. Who had his hand up? Sure.
Well, I have been reading about the SS7 possibilities for redirecting packets, and I don't know, the SMS for years. And is there some bright future, like they're replacing SS7 with something more secure, more prone to redirecting and injecting the messages by any other?
Yeah. The newer protocol. Well, you have the SIGTRAN, and then there's I forget the name of the new protocol. It's come out for 5G. I forget. It's improving, but what the weakness is going to be like for everything is the backward compatibility with it. But things are improving. But that backward compatibility and the features, like you said, the vendors are providing security features. They've got to go and turn them on, though.
In the talk after I will talk about diameter and 3G and 4G.
Yeah, diameter.
And
I can
5G,
remember
so,
that.
Yeah, diameter and GTP a bit.
Too much jet lag. I can remember.
Never mind. So actually, in this laptop here, there are two complete 4G networks in it. So.
Yeah.
So grab a coffee and come back afterwards for Silke.
Yeah.
Further questions? I think they all want to go for coffee.
Yeah. I
So-
need some too. Jet lag.
So the next talks will start at 4. So you have a prolonged coffee session. Thanks to Paul. So please give him a warm round of applause. Thank you.
Thank you. Appreciate y'all. Some of my talk. I hope it was of some use to you.